Hey, geometry family, let's talk more volume. So, up to this point, you should have learned some area formulas for polygons and circles. You should have learned volume formulas for prisms and pyramids. And now we're going to do one more volume formula and then kind of put some things together here. So, what we're going to do today is the volume of a sphere. And look at this, it's right up at the top. The volume of a sphere is 4/3 pi r cubed. The biggest mistake people make with this one is when they do the volume of a sphere, they do 4/3 pi r squared. Nope, it's 4/3 pi r cubed. All right. And the way to remember that is volume is always in cubic units. So you have to cube the r because it's the only variable there. All right, let's use it. Find the volume of the spheres below. All right, so this looks like, I don't know, a beach ball or a basketball or something. And it has a diameter of 30 centimeters. Well, the volume formula, being 4/3 pi r cubed, needs a radius. So my radius would be 15. So my volume would be 4/3 pi times 15 cubed. And then it says give your answers in terms of pi and rounded to the nearest tenth. So if I pull a calculator out to do that, remember to get it in terms of pi, I'm going to type everything except for the pi into the calculator. And then if I do it to the nearest tenth, I will plug the pi into the calculator. So 4/3 pi, skip it, r cubed. And look at that. I made the mistake that I always make, Mrs. Vibber. 4/3 times 15, there we go, cubed. That's the one I want. Kind of glad I made that mistake. Is 4,500. So my volume is 4,500 pi. And then if I want that rounded to the nearest tenth, I would do second answer times pi. And that's 14137.2. And there you go. Okay, and so now if we have a baseball and the radius of that baseball is 1.5, my volume is 4/3 pi r cubed. And if we put that into the calculator in terms of pi, 4/3 times 1.5 cubed, that's 4.5 pi. And just to save time, that's 14.1 if I put it in, I might as well do it, the calculator to get the decimal. Okay. All right, now it's not always that easy. Sometimes we have to go backwards. So this one says find the radius of a sphere that has a volume of 288 pi cubic inches. All right, well, volume equals 4/3 pi r cubed. Whenever possible, write out the formula first and then fill in what you have and solve for what you don't have. So it says find the radius if you know that the volume is 288 pi. So 288 pi equals 4/3 pi r cubed. If I want to solve for r, I need to get rid of the 4/3 and the pi. So I'm going to divide both sides by pi to effectively cancel the pi. Then to get rid of that 4/3, I'm going to multiply both sides by 3/4 because 4/3 times 3/4 is 1. So those effectively cancel. And so I'm going to do 288 times 3/4. Nope, that says 1/3. 3/4. There we go. And that's 216. And then, since this is r cubed, to undo cubed, I have to take the cube root of both sides. And so then this is going to be, how do I get the cube root? Well, if you look carefully at your calculator, if you hit Control and then the caret button, it makes the square root symbol where you can change the index. So I want the cube root of 216, and that answer is 6. Okay, so the next one says find the volume of an ice cream and ice cream cone shown below. I love ice cream in the summer. I am a cookies and cream person. I don't know about the rest of you. I don't want cookie dough. Yuck, it's just like little nuggets of sugar. I want a nice Oreo cookie. mixed into my ice cream. So we want to find the volume of the ice cream in the cone shown below. Well, if I want to find that total volume, the first thing you need to know is that I made a mistake when I wrote this one out. The answer is not 256.6. It is 166.8. So my apologies there. Change that. Okay, so we know what the answer is going to be. How did I come up with that? Well, let's see. If I have this ice cream cone, I know I have a hemisphere, which is half of a sphere. So that's 1/2 of 4/3 pi r cubed. And then I also have a cone whose volume is 1/3 pi r squared h. So I'm writing out the formulas before I go. And let's see here. 1/2 times 4/3 is really 2/3. So I have 2/3 pi, and my radius is 3.5. And then 1/3 pi, 3.5, and the height is 6. So then what you're going to do is take your calculator out and type all of that into the calculator, boop, 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 like how I pretended to do that, and you will get 166.8. All right. All right, now let's go to number 4. Now, I really think that you can do number 4 without me, so I would like you to pause the video and try to do number 4 without me. But before you pause the video, you should know that there's another error here, and this is supposed to be 811.6. So take a second, pause the video, okay, and then come back and check your answer. If you didn't pause it, pause the video. All right, hopefully you paused the video. If you didn't, I'm going to go through this at lightning speed. So for this one, I have a radius of 5 and a height of 7. So this volume is half of a sphere, 1/2 of 4/3 pi r cubed, plus an entire cylinder, which is pi r squared h, which is going to make this 1/2 times 4/3 pi 5 cubed, plus pi 5 squared times 7. And then you get a volume of 811.6. Now, what's tricky about this next one is that if you go through and do this, this 20 right here is actually the slant height. And I don't do a good job telling you that, so my apologies. If you thought that the 20 was that height inside, what you would have gotten there is 29489.1. So if you got 29,489.1, you can just call it a day and leave. However, the 20 was meant to be the slant height here. So what we would need to do is do Pythagorean theorem, 16 squared plus h squared equals 20 squared. And then you find out that the height that we really want is 12. So when we go to find the volume of this entire thing, I have 1/3 pi r squared h for the cone on top and pi r squared h for the cylinder on the bottom. And so that volume would be 1/3 pi 16 squared times 12 and pi 16 squared times 30. That should be a plus, not an equals. And then if you type that into your calculator, you get the 27,000 number. Okay, so my apologies if anybody didn't realize that 20 is the slant height. But if you did notice that it was the slant height, you would do a Pythagorean theorem there. Okay, so 3 I want to do together because we can talk about density here. So if a tennis ball has a weight of 58.5 grams and the diameter of a standard tennis ball is 2.7, what's the density of the tennis ball to the nearest hundredth? Well, density equals mass divided by volume. I'm looking for the density. The mass is 58.5. I need the volume next. Well, the volume of a tennis ball would be 4/3 pi r cubed because it's a sphere. If the diameter of the ball is 2.7, my radius is half of that, which is going to be 1.35. So my volume is, let's see, 4/3 pi times 1.35 cubed. And that volume would be, let's find out. 4/3 times pi times 1.35 cubed. And that's 10.306. And that makes my density 58.5 divided by 10.306, 5.676. And we want to round to the nearest hundredths, so that would be 5.68 grams per cubic inch. Now, normally we do density in grams per cubic centimeter, but this is given in inches, so this one is just grams per cubic inch. All right, copper has a density of 8.96 grams per cubic centimeter. What is the mass of a copper ball with a 10 centimeter diameter to the nearest hundredth? All right, so we're dealing with density again. Density is mass divided by volume. The density they gave us is 8.96. We want to find the mass, so I need to first figure out the volume. All right, well, if I have a 10 centimeter diameter, I have a 5 centimeter radius. So the volume of that copper ball is 4/3 pi 5 cubed. So let's see, that's going to be 4/3 pi times 5 cubed, 523.599. I'm going to write 523.6 just because I'm running out of room. And then if I want to find my mass, I need to multiply both sides by 523.6. Now, I'm just writing the 0.6. I'm actually going to use all the digits when I type it out anyway. So my mass is that answer times, what was it? 8.96. And I get 4691.45. And so my mass is 4,691.45 grams, or 4.7 kilograms. All right, last one. Tammy has a rubber ball whose circumference is 13 inches. She wants to box it for a gift, but can only find cube boxes of size 3-inch, 4-inch, 5-inch, or 6 inches. What's the smallest box that the ball will fit into? Well, I don't think I really need the volume at all here, right? If I want to think about this, we've got a box that looks something like this, right? Got to be impressed with my box drawing there. So I've got a box, and I want to fit a ball inside of it that basically like touches the edges. So I want to figure out what size ball do I need, or pardon me, what size box do I need to fit that ball in there? Well, geez, I should probably figure out the height of the ball. So if I have a ball whose circumference is 13, that means it's 13 inches around like this. All right, well, let's see. Circumference is pi d. That means 13 is pi d, which means my diameter is 13 divided by pi, 4.138. Oops, not 5, 8. So that means from top to bottom, this thing is 4.1 inches. So she needs a 5-inch box. No volume, no density, just trying to figure out what did I need for this one. And as a matter of fact, it was only the circumference formula. All right, my friends, I am done. I hope you're all having a great day. Continue having a great day, and I hope it's sunny outside today when you're watching this. Toodles.